Just like there was a sweet spot in the United States for solar, there's also a sweet spot for wind. This chart, which again is from the NREL, shows that the heartland of the United States is a great spot. This shows the wind potential at about 100 feet above the ground, 30 meters. And this shows at 80 meters or about 250 feet, which, if you think about it, is now the typical height of most wind turbines in terms of where the generator is located. And so you can see that the heartland of the United States, where it's happening, specifically the East Coast and the West Coast, not much happening at all. And again, this is where the location issue comes up, because that's where a lot of the the need for electricity is in the country. I have two great and short YouTube videos I'd like you to watch. The first is a little bit about the physics of the wind turbine, and what I want you to walk away with is an understanding of why there's a real practical limit as to how much energy can be extracted from a wind turbine. And this idea of rated capacity versus realized capacity, which is the wind doesn't always blow as hard as the turbine needs it to be blowing to produce its rated capacity. The second is a great time-lapse photography of the construction of an actual wind generator site. I think you're going to find it fascinating, and just pay careful attention to the weights involved. It's stunning to me that the concrete isn't buried deeper than it is to hold this thing up, but I think you're going to be surprised at just how much concrete really is involved in anchoring these things. So watch those two videos and you'll have a great understanding of the wind turbine. Now let's talk about tax credits again. Currently, the wind tax credit is 2.3 cents per kilowatt hour. What do you pay for electricity? I think I'm paying about 8 cents per kilowatt hour now, but you're going to see that 2.3 cents is pretty significant in terms of the economics when we look down the line. This chart is from the EIA product, and it shows a series of projections into the future, and you see there's all sorts of different projections from all sorts of different entities. But what you want to see is that in the budget negotiations in 2015, the end of 2015, where they extended the tax credits, they also sunsetted them in that they decline and then they're eliminated for sites that are not under construction before 2021. So what you can see is, again, making the point that all agencies, whether they are very renewable friendly or not, recognize that the tax credits are a key part of making these projects economically viable. So let's take a look at, I was amazed at the parallels between putting in a wind farm and drilling a well. So the first step is you got to figure out well, or where. In this case, we have not only the generalized wind data, but that's called a Met tower that often firms will build because there are significant geographical effects of the terrain that affect wind. And so they actually put out poles to measure the wind velocities at the altitudes that they're concerned about. Then you have to gain the right to lease, and we'll talk about the amounts of money that are typically involved. But just like not everybody is thrilled about oil and gas drilling on their lands, a lot of people aren't thrilled about wind turbines on their land, and gaining the right is not easy. Over time, there's evolving standards as to where they'll be located. If you've ever been around them, they do generate noise. Not as much, frankly, as I thought they would based on all the hype I'd heard. But if you're downwind of them for several hundred feet, you're clearly going to hear it. The impact on animals is still being debated. But I know that I've talked to some farmers in West Texas that say their cattle love the towers because they can tell on the hot afternoons they're all lined up in that little thin shade that the tall mast creates. Then you have to build it, and we've seen about that. And then the last thing that you don't always think about is you have to connect it in. Now, as I was taking one field trip with the class up to Electra, we pointed out that big wind turbines, or I'm sorry, not to Electra, but south of Vernon, we pointed out all the wind turbines that are between Electra and Vernon, Texas. One of the reasons that that's a great place for them is they sit right on a major transmission line, so it was very easy to tie in to the existing grid. In this sense, it's like an oil and gas operation that you'd like to build near or drill near an existing pipeline system because it's easier to tap in. And this idea of building electrical lines is a lot more challenging than it seems. There are some companies that want to take wind out of Kansas and put it into Tennessee, but obviously they have to build a power line through Arkansas to make that happen, and Arkansas hasn't granted them permission. It's what's in it for me? Nothing. And so this is a challenge to gain the right to build the power lines, to move the power from where it is generated to where it's going to be used. I told you that my brother-in-law is the land commissioner of New Mexico, a project that started before he went into office and will continue probably until after he gets out of office, is a power line called the SunZia power line, which has to be routed through a lot of state trust lands in New Mexico. And so this is the route of the SunZia. It's designed to take winds out of a sweet spot in south central New Mexico and push the energy created into the Phoenix and Tucson markets. However, just to give you an example of the right-of-way, the deal that the land office is negotiating with the power holder is that they want basically $1 million a mile in leasing. And they're saying that they want 50% of that money up front, the rest paid out over an extended number of years. So think about that. If you have a 200-mile power line crossing state trust lands, it's already a $200 million project just to gain access to the land. And so these are some real challenges. I'm going to end this presentation. Well, actually, I'm going to go just a little bit further. This is wind capacity in the United States. This is from the American Wind Industry Association, so very wind friendly. Notice the state that is #1 in wind power, Texas. Not even close. In fact, you can sum the #2, the #3, and the #4 state, and combined, they don't quite match the wind capacity in Texas. Notice the states where there's no wind capacity, and it makes sense. The reason you see so much in California is because they mounted them in a couple of strategic areas where the wind really blows. But not surprisingly, you see where the wind capacity is. This is currently today, the fall of 2017, the wind projects that are under construction. You can see New Mexico's almost going to double. Wyoming, significant advancement. Oklahoma, significant advancement, but all smaller. You can add up all that addition, and it still barely matches the additional capacity that's going to be added to Texas this year. So whether you realized it or not, in terms of wind energy, you are living in the wind capital of the world. So then the question becomes, why Texas? Why is Texas the wind capital of the world? Well, this is where I'm going to end the video presentations, and this is where we're going to pick up in the classroom discussions.